Interval notation. Let's talk about interval notation. So say that we have bracket A comma B bracket. Bracket tells me that we are including that point, right? On the number line, we are including it. This is a closed interval, meaning that we are closing at A and we're closing at B and everything in between them. So let's write it in a set builder notation. So we have some set that builds on X. That's what that says. My writing is just a little off right here on this bracket here. Okay. Now let's make our statement. It says that A and B on that line has something floating between it, which is X, because we're saying we're building the X, this interval notation about X. So I'm gonna put X here in the middle. This bracket on A tells me that X is gonna be greater than that A and equal to it, because it can equal it because it's closed at A. And then this tells me that X is less than or equal to B. So this tells me that when I draw it out on the number line, and sometimes it's easier if you draw it first, the X is going all in between A and B. And since it's got a bracket, we are closing it. It would be a closed circle if we was to put circles on A and B. Let's write it as inequality notation. Well, it's strictly A is less than or greater than, or excuse me, A is less than or equal to X, which is less than or equal to B. What if I had a bracket on A and a parentheses on B? Well, this is an open closed interval, meaning we're closed at A and open at B. Parentheses literally tells me it's open. How do I know that? Because when I go graph this here, I would have an open circle on B, right? I'd have a parenthesis. That means X is approaching B, but it doesn't include B, but it gets really close to it. But X does include A. Okay, so now let's write our set builder notation. So X builds on where A is less than or equal to X, which is less than B. So my inequality notation is going to be A is less than or equal to X, which is less than B. Let's do where A is open and B is closed. And again, it's open, closed. I'm going to draw it on the number line. A, B. Sometimes drawing it on the number line, and whenever you do application problems, if you can draw a picture, sometimes it helps you to determine what's the final result, what's the answer. And putting it on the number line helps write it in interval notation, because sometimes you're not giving the interval notation, you're given some kind of equation or application problem you got to solve, and then you got to write your final answer on the number line. Drawing it out here will help you. So it says A is opened. So I'm gonna have a parentheses. That means we're not including A, but we're getting close to it. B has a bracket on it. So that tells me B is included. Okay, so let's come over here and let's do the set builder notation. So we have this set that builds on X, where my A is less than X, less than or equal to B. So my inequality notation is A is less than X, which is less than or equal to B. So what if both ends are open? Well, it's just an open, right? It's just an open interval. Come down here, we draw it on there. We know that A gets an open circle if I was to write a circle. The circle here, or you can just put the parentheses brackets. I like using the parentheses and brackets. It means X falls in between there, but without including A and B. My set builder notation has X that builds on where A is less than X, less than B. And then my inequality notation is A is less than X, less than B. Now, what if I have this stuff going on where it goes negative infinity to A and A is closed? Remember, you cannot stop infinity. So you're going to always have a parenthesis on infinity. It doesn't matter if it's infinity to infinity, however it goes, you cannot close infinity. So remember, do not put a bracket on infinity. So let's write this out the way I see it. A is right here and we're including it, but we're including all points less than, right? All negative values. That means it's going to be to the left. We're going off to negative infinity. So I have this set that builds on X where X is less than or equal to A because A is included. So now I got, let's write it, X is less than or equal to A for the inequality notation. Well, I could also have where A is not included. So I'm going to use a parenthesis. And if I misspoke a while ago, my apologies. A is included in this one here because of the bracket. It's closed at A. Here is opened at A, so we're not including it. So I have a set that builds on X, where X is still less than, but not including A. So here is my notation for inequality, and let's draw it out on number line. And I got parentheses, don't go past A, you're drawing it out. Now let's do B. B's the same way. If B's, or let's do A. Let's do A again, sorry. I'm just gonna use B because we've been saying A all the time, but we can use it A. We're including A here, going off to positive infinity. So when I draw A here, I know it's a bracket. It's going all the way to the right. We're including all positive values. Then that means my inequality notation is X is greater than A, right? And it's a set builder that builds on where X is greater than A. Now I can say, okay, it's open to A. We're not including it, but we are getting close to it. We can draw it on the number line. It's a parenthesis, goes off to positive infinity. So I got the set that builds on X, which is greater than A. And we left the equal to sign off on the one above us right here, the closed one. Since we are including it, guys, I apologize if I misspoke here, and if you caught it, kudos. Since we're including it here, it is X is greater than or equal to X is greater than or equal to. This is another good reason why to draw it out. You can catch these little typos. We are human. Sometimes we make them. Just definitely catch them before it gets too far. But this last one here, it's closed on A, so opened on A, I would not have the equal sign. Again, closed means we're including that point and you put a bracket. Open means we're getting as close as we can to that point without including it. And it's open. Also, infinity is open. Negative infinity is open, meaning we cannot stop on it. So let's talk about writing these out. The first one's already an interval notation. So what I want to do is write it in a set builder notation, inequality notation, and graph it. So what I'm going to do is graph it first. I got -2, 3. And if you notice, they always write the smaller number first because we always read left to right. It says that -2 has a bracket, so it's closed on -2. 3 has a parenthesis, meaning it's open. And it's going to be all values in between. So when I write my set builder, I got the set that builds on X, where -2 is equal to or less than X, where X is less than 3. There's my set builder notation. Well, that tells me what's my inequality notation, right? We got that down. We got our number line drawn, so we are good. Let's clean this up right quick. Now let's do B. I am just determined to mess that up, ain't I, guys? Let me get this cleaned up. Let's write 3. All right. This next one, though, is written in inequality notation, but not interval and not set builder and not line. So let's draw the line. We got 5. It says X is greater than 5. So we know we're going off positive infinity. It says it's including 5. Because the equal to, so we know we got a bracket on it. So my interval notation would be bracket 5, positive infinity, parenthesis. And my set builder would be a set that builds on X, where X is greater than or equal to 5. Well, see, our inequality notation comes from the set builder. Let's solve the first degree linear inequality. All right, so we have this linear inequality right here. We have this linear, which is a first degree, and the inequality, right? That's less than here. So let's solve for this. Well, some people likes to replace the equality sign with an equal sign. If you want to do that, that is fine, guys. Just make sure at the very final end that you put the inequality back and be careful, okay? I like to leave my equality sign because of the simple fact there's a few rules that goes on, and I'm going to get to a part and where I'm going to explain that in a minute. Our final answer is going to be interval notation, and we're going to draw it on the number line. What I noticed though is inside this parentheses, I cannot combine it, but I can distribute this 2 on the outside. So let's do that. 2 times 2x is 4x. 2 times 3, which you notice they're all positive, so it's going to be 6 less than, and I'm going to distribute the 6 to everything inside that parentheses because I can't combine it here and clean it up. So now let's go ahead and distribute 6 times x. It's a positive 6 times a negative 2, so it's a negative 12 plus 10. So I'm going to bring down that 10. Now, before I move all my variables to one side and all my constants to the other, I'm going to clean up any like terms. And I notice this negative 12 plus 10 is a like term. So I have $10, I spent 12, so I'm in the whole 6. All right. So now let's get all the variable terms on one side. I noticed that I like to read left to right, and I noticed this 6x on the side here, it's positive. So let's subtract it. It makes it go to 0. That's what I wanted. Now I got 4x minus 6x gives me a negative 2x. Now I need the 6 by to be on the other side, right? I need the x by itself. So what I'm going to do is I'm going to subtract the 6 from both sides because it's positive, make it go to 0. Now I got negative 2x is less than, I spent $2, I'm in the whole 6, so I'm in the whole 8. All right. Here is that rule. If you did not replace this inequality sign, if you were using equal all the way down to here and you didn't replace it, you can make this one little mistake right here. And this is why I like to keep it. Is whenever you divide by a negative number to get the positive 1 coefficient, remember it has to be a positive 1 on the variable, right? It is a negative 2 here. If it was just 2, then this rule wouldn't matter. It would just be dividing by a positive 2. In this case here, we're dividing by a negative 2. That means we got to force the negative sign through the inequality. Whenever you force the negative through the inequality, it causes that inequality sign to flip. Now I got negative divided by negative is positive. 2 goes into 8 4 times. My answer is x is greater than 4. Remember that this negative sign here forced through the inequality sign causes it to flip. So now I already got it written in inequality notation. Let's write it in interval notation. Well, let's draw it out first. It says x is greater than, so that means we're going to shade off to the positive infinity. There is no equal sign, so that means that we're approaching 4 without including it. So it's a parenthesis. So 4 and infinity gets a parenthesis, so it's interval notation. So I answered this 3 ways. All right, so let's go to our next example. Solve for x. Well, I notice here I have 2 sides going on, right? X has things going on both sides of it. So I look at this middle part and I need to clean it up. I also see that I got inequalities, right? So I got a lot going on. 2x plus 3. What I need to do is subtract this 3 from both sides. When I do that, now I got negative 3 minus 3 is a negative 6 is less than 2x less than or equal to 9 minus 3 is 6. All right, we're doing good. We still got a lot going on here. However, let's look at what's the coefficient on x. It is a positive 2. If it was a negative 2, remember, it would change everything as far as these inequality signs go, but it didn't. So we're going to divide by positive 2. What you do to one part, you got to do to all 3 parts. You notice there's 3 things going on here. Now I got 2 goes into -6. That's positive 2 into -6. -3 is less than x, less than or equal to 2 goes into 6, 3. Okay, so this is my inequality notation. We need to write it in interval and we need to graph it. Let's graph it first. So I got -3 here and I got 3 here. X is floating around in here, right? And it says -3 is not included, but we're getting as close as we can to it. I'm gonna put a parenthesis there. It says 3 is included, so I'm gonna put a bracket at 3. You gotta do better than that drawing. That's kind of hard to do. Now I got it written where I can write it in interval notation. And boom, I answered my question in 3 different ways, right? And then using the number line, using the inequality notation, and interval notation.